This is typically how a host is connected to the internet. This host is part of a physical network. I am representing a physical network by an Ethernet segment, but this can be an extended LAN, it could be a switched Ethernet, whatever it is, they're all part of the same physical network, or the link layer is kind of the same across them. Now, if host A wants to send a packet, so basically it generates this particular packet, and then it has a destination field as part of that particular packet. So this is being done by the higher layers. Now, if the network number of this destination is the same as the network number of host A, then it knows that this destination belongs to the same physical network, in which case it can deliver the packet directly to the destination. It doesn't have to go through the router. So for this, if it figures that out, it is going to use the ARP to get the MAC address. We will cover ARP shortly, but ARP basically gets the MAC address corresponding to a destination IP address, and once it gets the ARP address, it is going to encapsulate this packet with a link layer address corresponding to the MAC address of the destination, and then send out this packet, which kind of, in this case, for example, if the destination is host B, it just goes in this fashion. But on the other hand, if the network number of the destination does not match its own network number, that means it is not in the same physical network, it has to go through the router, in which case it will use ARP to get the MAC address corresponding to the router. So this packet with this destination IP address is encapsulated with another link whose destination will correspond to the router. And then this packet now goes to the router, which will then figure out how to send this packet out into the internet. So if you want to know the routing table that the host employs in Linux, you could use this command. So this is the kernel routing table. If you type route, it will show something like this. So in this case, there was a name lookup done. In this case, -n means don't do name lookup. Both kind of give the same information, whereas here it is giving IP addresses, here it is giving the host name. So what is this table telling? Let's look at it here. So it is saying if the destination has this address, so this is the network portion, the mask typically says how many bits correspond to the network portion. So here it is saying look at the first 2 bytes. So this is which address is this? Class ABC. Actually this is a class A address, but the mask is saying to look at the first 2 bytes. That is kind of indicating that this is a class B address. So why this discrepancy? We will cover it later. For now, just view the mask as saying what bytes within the address you should look at. This is saying look at the first 2 bytes. So I'm going to look at the first 2 bytes of the destination address in a given packet. Now, if the first 2 bytes match this 10.129, this is saying send it out on interface 80. So what is this link local address? If you look here, link local address is corresponding to this. This is not a loopback address, by the way. This is a link local address. Link local address is used for communication between hosts belonging to the same physical network. So this can at times arise when you are not able to get an address from some server like DHCP. Again, these things will become clear later when we cover DHCP. So even in this case, it is saying if it's a link local address, send it out on the interface ETH0. And if these two don't match for anything else, send it to the router. This is the gateway on ETH0, because hosts are typically connected to the router on the same interface. The difference, if any, is in this particular case, the ARP gets the MAC address corresponding to the destination IP address, whereas in this case, the ARP gets the MAC address corresponding to the router. So what are these other entries? Gateway says whether the packet has to go through a gateway. Since these are all local, it doesn't go through a gateway. This is going through a gateway. Mask, as I said, identifies the network portion of the address. Flags U flag tells whether the path is active. In this case, it is active, so U is set. G flag says that the path is active and it is going via a gateway. Metrics are used for assigning a weight to a path. This comes as part of the routing, but typically suppose a host has two interfaces, let's say ETH0 as well as ETH1, and you want, when you are routing packets to the outside internet, you always want to use ETH0 over ETH1, in which case you set ETH0 to a lower metric and set ETH1 to a higher metric. This forces the process to always use ETH0 as the default interface. This ref use are not used in the Linux system, so I won't get into this. Interface specifies what interface you have to send this packet out on. Typically here, unless you have multiple interfaces, this will be the one interface that a host has. So here is the IP table in Windows machine, so you can obtain this via the root print command. Lot more entries as part of the Windows routing table. I won't get into lot of details. Let me just mention that this is the IP address of the host itself, so it maintains a routing entry for the host itself. This is the broadcast address in that particular physical network. This, as I said, is the loopback address. This is the broadcast address corresponding to the loopback address. And then this is a multicast address, and these are again broadcast addresses. So it maintains lot more entries. In Linux, these are all executed, but they don't necessarily be part of the routing table. So as you can see here, for anything that doesn't have an entry, this is the default entry, which is saying go via the gateway. So here is how forwarding is done at a router. So this figure shows how this router is attached to 3 physical networks and also connected to another router, which in turn connects it to the internet. So for this particular router, whenever it receives a packet, it looks at the network number of the destination address within the packet. If it matches any of its network interfaces, the net number of any of its interfaces, then it delivers the packet directly over that interface, again using ARP. Else it will look up its forwarding table. If this forwarding table says to deliver it to some router, for example R1 can also be hooked to some other router R3. If it says deliver to R2, it will deliver to R2. If the forwarding table says deliver to R3, it will deliver to R3. Typically routers also have a default router. In case there is no entry as part of your forwarding table, this router will forward it to some other router, which in turn will forward it further. So here is a summary of what we have seen so far. Anything you do at the network layer is all about scalability. This is our top concern. And we have handled this through this hierarchical addressing, where an IP address has 2 portions, a network portion and a host portion. This can significantly reduce the entries in the forwarding table. Now, based on this addressing, we also saw how a forwarding is done at a host as well as the router. Life is never easy. You think you have solved one problem, you get bombarded with other problems. So as the internet size grew, this addressing was still found not to be scalable. You had to address other issues. We will look at it in the next video. We will address the address assignment inefficiency and solutions to the same.